All right, so one of the most important probability density functions is the normal probability density function. Now it's defined as follows and graphed in figure 3 down here. So it's the normal, the bell-shaped curve. That's the one everybody knows. And so what it is it's f of x is equal to 1 over the standard deviation times the square root of 2 pi. All that is on the outside because those are all just numbers. Then we have e to the minus x minus mu, which is our mean, and then squared all over 2 times the standard deviation. Okay. Now it's going to be shown not easily that the area under the normal curve in figure 3 over the interval from negative infinity to infinity is exactly 1. All right, so since this integral from of e to the negative x squared dx is not integrable in terms of elementary functions, that is, the antiderivative can't be expressed as a finite combination of simple functions, then the probability is such that we're going from c to d of 1 over that sigma square root of 2 pi, from c to d e to the minus x minus mu squared over 2 sigma dx. That can be computed using numerical integration command on our graphing calculator. So basically, we can type all that into our calculator and we can get an answer. So that's kind of nice. So that's what we're going to do on this one. And so it says, what percentage of the LED floodlights in this example below can be expected to last between 7 and 11 years? All right, so we want basically the probability that 7 is less than or equal to x is less than or equal to 11. And now we're going to use our function. So maybe we should write that over here because remember, there's not much room, but we'll write it here maybe. Probability c less than or equal to x less than or equal to d is equal to 1 over sigma square root of 2 pi, and that's from c to d, and that was e to the minus x minus mu squared over 2 sigma squared, and then that's dx. So now we're just plugging in sigma. Well, standard deviation, they say, is 2. So that's going to be 2 square root of 2 pi. And integral from 7 to 11 of e to the negative. And now we have x minus mu. Well, mu is the mean, which is 9 squared all over 2. And that's going to be 2 squared and then dx. Now we get to write that out into our calculator to get our answer. We don't have to do it this way, by hand. So they're letting us do a calculator here. So we have 1 divided by, and then we'll have 2, and then square root of 2 pi, and then in parentheses. And now we have math 9, and we're going from 7 to 11 of, now we have e, and now we have a negative, and then we have x minus 9, so x minus 9, and that quantity squared, and then divided by, and then on the bottom we have 2 times 2 squared, and then that's that, and so now we have that parenthesis, and everything's closed, I think, and then dx. And we get 0.682689 or whatever. And so what we'll write down is we had, well, that was equal to 0.68269, I believe. And so that was going to be, now they want this as a percent. And so when they want it as a percent, then what we have to do is convert that to a percentage. So that's going to be 68%. And we're going to assume that they want it as just whole number. We're not going to have a 68.3 or whatever. We're just going to round it to 68%. All right. So again, being able to type that into your calculator is going to help you on problems like this, where we really can't do the antiderivative very easily. And so we just plug it in and get our answer that way. All right. So let's stop there and come back for more.